Hello class, moving on to 16.3. Our learning target for today is going to be calculating and interpreting the mean absolute deviation. If you take a look at page 1096 in problem number 1, we are on to the championship. But who should we start? If you take a look underneath that, it says, previously you examined the points scored by 3 players on the Olive Street Middle School girls basketball team. Suppose the team won the game and will advance to the district championship. Coach Harris needs to choose between Tamika and Lynn as starters for the game. In the past 6 games, Tamika scored 11, 11, 6, 26, 6, and 12 points. And in the past 6 games, Lynn scored 15, 12, 13, 10, 9, and 13 points. So you can see then that they show the dot plots for each player's scoring over the past 6 games. You have Tamika up on the top, and you have Lynn right underneath her. You can see that the mean is 12 for both of the girls, as indicated by the black triangle underneath the 12 in both of the dot plots. What I would like you to do to get started today is answer number 1 with your group members. Based on the dot plots, which player do you think Coach Harris should choose? In looking at some answers for number 1, I think everyone's answers are going to definitely vary, but a couple of things that you might have come up with, choosing Lynn. You can see from her dot plot that her scores are definitely more consistent as far as how many points that she scored in the game. Tamika, maybe because she had a game high of 26 points in one of her games. So a couple of different things to look at as far as which one he should choose. So let's help Coach Harris make this decision. It says at the bottom of page 1096, when analyzing a data set, measures of center give you an idea of where the data is centered or what a typical data value might be. There is another measure that can help you analyze data. Measures of variation or variability describe the spread of the data values. Just as there are several measures of central tendency, there are also several measures of variation. The deviation of a data indicates how far that data value is from the mean. In order to calculate the deviation, you're going to subtract the mean from the data value. So let's take a look at number 2 at the top of page 1097. It asks us to calculate the deviations for the points scored for each player using the equation. Remember that equation was the data value minus the mean. It asks you then to record your results in the table. You can see that Tamika's deviation table is completed for you. And I just want you to remember from the previous page that the mean for both of the girls was 12 from the dot plots on the previous page. So go ahead and fill out Lynn's table with your group members. So if we take at Lynn's table and we describe the deviation from the mean, hopefully this is what you came up with. If she had 15 points scored, that would be 3 more than the mean. Again, remember the mean was 12 for both girls. 12 is the mean for 12 points scored. 13 points, that would be 1 more than the mean. 10 points would be 2 less than the mean. 9 points would be 3 less than the mean. And 13 points would be 1 more than the mean. And if you want to write it this way, instead of actually writing it out in words like I did, it might actually help out or be a little easier to understand for one of the upcoming questions that we'll have. Take a look at number 3 and number 4 then underneath those 2 tables and go ahead and answer them with your group members. In looking at your answers to number 3 and number 4, first, number 3, what is the meaning if a deviation is less than the mean, more than the mean, or equivalent? That's simply just going to tell you each data point's value that it is away from the mean. So how far away from the mean that it's going to be. For number 4, what do you notice about the deviations for each player then? If you really take a look and kind of analyze it, hopefully these are some of the things that you saw, in addition to maybe some you came up with on your own, some others. Half of Tamika's deviations are less than the mean, so in most of the games that would mean that she scored less than 12 points. Lynn's deviations, on the other hand, are mostly more than the mean. Only 2 of her deviations are less than the mean, so that tells us then in most of the games she scored more than 12 points. Let's turn to page 1098 and take a look at number 5 up at the top. Carly claims the sum of the deviations for a data set will always be 0. Do you agree with Carly's statement? Why or why not? Go ahead and answer that question with your group members. I thought it would be easiest for number 5 to actually write down the deviations for both girls from the tables that we used on the previous page, 1097. So if you look at Tamika and you add up all of those deviations for her data set, you would see that you would get negative 14 if you added up all of those deviations that were less than the points that she scored. And then you have your 14 there, so those would cross out and give you your 0. Over to Lynn's side, if you added up all your positives, you have 3, 1, and 1, which is going to give you 5, and then you have your negative 2 and your negative 3, which is going to give you negative 5. So that would also give you 0. So hopefully you agreed with Carly. Since the mean is a balance point, the values less than the mean need to balance the values that are greater than the mean. Based on the work that we did in number 5, it says the sum of all the distances less than the mean are equivalent to all the distances greater than the mean. Because the mean is the balance point, the sum of data points on either side of the balance point are equivalent to each other. Now, in order to get an idea of the spread of the data values, you can take the absolute value of each deviation, I'm going to highlight that word right there, and then determine the mean of those absolute values. Now, just to make sure you get an understanding of what absolute value is, the absolute value of a number is its distance from 0 on a number line. So if you just look at the number line here that I have created, if you look at 1 here, the absolute value of 1 would be negative 1, or vice versa. The absolute value of negative 1 would be 1. If you had a number a little farther down the number line, let's say you had 6, the absolute value of 6 would be negative 6. So just a quick reminder that the absolute value, like I said, of a number is its distance from 0 on a number line. So the absolute value of each deviation would then be called the absolute deviation. The mean absolute deviation is the average or mean of the absolute deviations. So in number 6, if you take a look at the 2 tables for Tamika and Lynn, they're asking you to determine the absolute deviation for the points scored for each player. Record your answers in the tables. Remember, the absolute deviation is simply the absolute value of each deviation. So take a look at that middle column and then come up with the absolute deviation for Tamika and Lynn. Here are what your tables should look like for Tamika and Lynn. Let's look at Tamika first. The absolute deviations for negative 1 would be 1, negative 1, 1, negative 6, 6, 14 would be 14, negative 6 would be 6, and 0 would be 0. For Lynn, 3 would be 3, 0, 0, 1, 1, negative 2, 2, negative 3, 3, and 1, 1. Take a look then at the top of page 1099. What I would like you to do is answer number 7, 8, and 9 together with your group members, and then we'll discuss the answers. So here is what 7, 8, and 9 should look like at the top of page 1099. If you look at Tamika first, if you take all of those values in the right column, her absolute deviations, and add them all together and divide by 6, in order to find the mean absolute deviation, you would end up with 4.6 points. If you had 4 2/3, just convert that to decimal form. Then if you move over to Lynn, if you take her absolute deviations, add all of those up in the right column of her table, and divide by 6 in order to find the mean absolute deviation, you would end up with 1.6 points. for Lynn. Again, that would be 1 2/3 as a mixed number, just converted to a decimal. Now, for number 8, what does this mean? What does the mean absolute deviation tell you about the points scored by each player? What this is going to tell us is that Tamika typically scores within 4.6 points away from the 12 points in a game, which remember represented the mean. Lynn, on the other hand, typically scores within 1.6 points away from those 12 points in a game. So if you look down then at number 9, if you were Coach Harris, which player would you choose to play in the championship game, and give an explanation of why? I'm hoping that you would choose Lynn. She's more consistent in her scoring, close to 12 points in a game. I know that Tamika scored 26 points in one of the games, but she also might score a lot less than 12 points in a game. So her scoring pattern is too inconsistent. Lynn is more consistent, and therefore that's who Coach Harris should choose. Let's go ahead and move on to problem 2 at the bottom of page 1099. Now we are going to be determining the absolute deviation of 2 data sets. So it says, let's examine the 2 data sets and their dot plots which you previously created. If you see set 1 over on the left and set 2 over on the right, these are the dot plots that you created back in 16.2. So go ahead and answer number 1. It asks you, which data set do you think will have the greater mean absolute deviation, and explain your reasoning. In looking at both data sets, hopefully you came up with set number 2. That should have the greater mean absolute deviation because the data are more spread out. You can see that 25, that more extreme value, down on the left end of the number line. So let's go ahead and finish up today. If you turn to page 1100, up at the top, number 2 says calculate the mean absolute deviation for each data set. You can see set 1's table is on the left and set 2's table is on the right. Go ahead and do that with your group members. In looking at both tables, let's start with set 1 first. You can see the middle column as far as describing the deviation from the mean, and the right column what the absolute deviations are. If you would end up adding all those numbers up and dividing by 5, your mean absolute deviation, or abbreviated MAD, would be 4. For set 2, you have your middle column again describing the deviation from the mean. Your right column is your absolute deviation. If you take all those numbers in the right column, add them up and divide by 5, you get 10 for your mean absolute deviation for set 2. Finally then, if we take a look at number 3 down at the bottom as far as interpreting each of the mean absolute deviations, remember we're trying to figure out how far away from the mean we are. In set 1 then, on average, the data values would be 4 away from the mean of 55, and for set 2, on average, the data values would be 10 away from the mean of 50. That'll do it for 16.3. Please let me know if you have any questions. Thanks.